Hello viewers, welcome to this video. I'm Venkat and this is just me, an open source channel. Right, in this video, I'm going to show you how you can set up Nginx Ingress controller in your Kubernetes cluster. So I'll just walk you through with my notes to understand what an Ingress controller is, what it can do, and then I'll show you a quick demo of how you can use the Nginx controller to routing the traffic. Right, as usual, I'm gonna bring my notes here. So my infrastructure for this video will be my host machine, which is a Dell XPS laptop with 8 core and 16 gig RAM, running Manjaro Arch-based Linux, kernel 4.19. And my infrastructure will be, I'm going to set up a K8s cluster, Kubernetes cluster with one master node and two worker nodes. All the nodes will have 2 cores and 2 gig of RAM, and they all are CentOS 7 machines. And for this demo, I'm going to be using a HAProxy as well. So that's again another virtual machine. And all these are not VirtualBox, a proper virtual machine. So this one, HAProxy, and the 3 Kubernetes nodes are all going to be LXC containers. So if you haven't followed my previous video where I showed you how to set up a Kubernetes cluster using LXC containers, I would suggest you to go and watch that video. But that doesn't matter. If you've got any form of Kubernetes cluster, you can follow this video. But if you want to know more about the LXC containers, I've done a video on it. You can search getting started with LXC containers. And then if you want to know how to use LXC containers to provision Kubernetes cluster, it's how to set up Kubernetes cluster using LXC containers. So those are the 2 videos if you're not aware and if you want to know more about those. But for this video, I'll just go ahead with the LXC containers. Right. I've already got the cluster up. kubectl version -- short. So server version is 113.4. kubectl get nodes. So I've got 3 nodes. kubectl get nodes -o wide. So I've got 3 nodes: master, kworker 1, kworker 2. All are CentOS 7 virtual machines. Docker version 18.6.0. Okay, so that's all looking good. And if I do LXC list, so those are these are just the LXC containers. So LXC containers with the IP addresses. So they're all running. And let's go back to the nodes. Okay, so so far I have never used Ingress in any of my tutorials, any of my videos. Okay, so how it works and why do we need an Ingress? Okay, so basically when you deploy your application with number of replicas, say 3 replicas in this case, and 2 replicas running on 2 pods running on one worker node and another pod running on a different worker node. So the next step to give access to the application is you will create a service. Okay, so you're creating a service of type node port. So once you create that service, every single worker node in your Kubernetes cluster will have the node port. Either you configure what port you want in your node port in your service configuration, or you just let Kubernetes decide a random port. So once that's done, from your client side, from any machine, if you know the IP address of any of the worker nodes, you connect to that IP address and on the node port, and you will be able to get to the application, get to the running pods. Okay, so node port, so that's the way it works. You need to know the IP address of any of your worker node. Even if there is no pod running on this worker node, and say your deployment has got just one replica, one pod running on this worker node, even in that case, if you access kworker 2 on the node port, it will be able to route the traffic to kworker 1. So that's because of the flannel network, which is an overlay network that's span across all the worker nodes. So you don't have to worry about where your pod is actually running. You can connect to any of the worker node on a node port, and then it will route the traffic accordingly. So the service is responsible for load balancing. If this node dies, if this pod dies, and then this service will take care of it. It will the replica set will take care of bringing that pod up again. But meanwhile, this service will route the traffic only to the healthy pods. So the load balancing is done by this service resource. So we don't have to worry about anything. Okay, so that's a development or a testing scenario. What if you run a production cluster and if you want to give your end user, your customers, access to your application? You don't want to give them the IP address of your worker nodes. The IP address may change. You may decommission your worker nodes. You may expand. You may scale out or scale in your worker nodes. In that case, they don't want to remember the IP address of the worker nodes. So if you deploy this application in a cloud, Google Cloud or Amazon or Azure, when you create a service of type load balancer, it's going to automatically provision a load balancer for your application. So you don't have to worry about anything. But all my videos are based on bare metal. So for bare metal, we have to take care of the load balancing. So that's where Ingress comes in. Okay, so look at the same example. So you've got a couple of worker nodes. You deploy an application that's span across multiple workers, running pods on different worker nodes. And now you create a service of type cluster IP, not node port. You create a service of type cluster IP. So this IP will be accessible inside the cluster, not outside. So then what you're going to do is you're going to deploy an ingress controller, which routes the traffic. Okay, so this ingress controller can be a daemon set or a deployment. If you run it as a daemon set, in an ingress controller gets scheduled on every single worker node. If you've got if you've got 100 worker nodes, then if you create a daemon set, the ingress controller will get deployed on your 100 worker nodes. But that's not always required. You don't have to always go with the daemon set. Although I'm going to show you the daemon set way in this demo, you can also create a deployment with say 5 replicas, 10 replicas. So if you've got like 100 worker nodes, and if you create a deployment for this Nginx controller for 5 replicas, it only runs on 5 worker nodes. It doesn't have to run on every single worker node. So at least it runs on one or more worker nodes, it should be fine. It doesn't have to be run on all the worker nodes. So it can be either a deployment or a daemon set. Okay, so that's the ingress controller. So that's the software that takes care of routing the traffic. And then we need to define an ingress resource. We need to deploy a resource. Resource are just basically rules that says, okay, so when a request comes in for this address, route it to this service. That's it, plain simple rules. So when you create a rule, every single ingress controller will get that rule and configure them based on the rules. Okay, so for example, you create a DNS entry for nginx.example.com, and before that, you also need a HAProxy. You create a HAProxy and you add all your worker nodes to that HAProxy. You can use any load balancing solution, but for this demo, I'm using HAProxy. So HAProxy is going to load balance your request to all the worker nodes. So basically, you're adding all your worker nodes to the HAProxy. And you're going to create a DNS entry for nginx.example.com or any name that you want in your DNS server, and point all the entries to HAProxy's IP address. So basically, all your requests are going to HAProxy. And then HAProxy will load balance between any of the worker nodes, and the ingress controller will know where to route your traffic. Say if traffic is coming for nginx.example.com, it will read the ingress resource rules and it will route the traffic. So if it comes from nginx.example.com, it knows it needs to route the traffic to this service. So that service will then load balance between the available healthy pods. So there are two load balancing in this demo. So one is the HAProxy that load balance your worker nodes. It can take you to any of the worker nodes. So the end user only needs to know the the name of the application, the URL of the application. For example, nginx.example.com, myapp.example.com, and so on. And in your DNS server, you would have made entry for these URLs pointing to the IP address of the HAProxy. So that load balances these worker nodes, and the ingress controller will know where to forward the traffic to, which service to forward. Depending on the URL that you type in, it knows where to forward the request. So it forwards the request to the appropriate service, and that service will load balance the pods. Okay, so ingress controller. When you deploy an ingress controller, we're going to see how we can do that. But basically, it's going to create a namespace, a service account, a cluster role binding, config map, secret, and a daemon set. So that's a general concept of ingress controller. There are various ingress controllers that you can use. So in this demo, I'm going to use Nginx, and in my next video, I'll be using something called traffic. Okay, so we've got our cluster ready. We've got the clusters ready, which are all LXC containers. So I'm going to create a HAProxy now. This virtual machine. Okay, LXC list. So I've got those three machines. LXC launch images CentOS 7 HAProxy. So that's going to create a CentOS 7 virtual machine. Basically, it's just a container, a lightweight container. So let's wait for that to create. LXC list. All right, the machine is ready. If I do LXC list again, you can see HAProxy. LXC list HAProxy. Cool, and it has got an IP address. So now I'm gonna git clone my Kubernetes repository. Git clone https github.com just me and open source Kubernetes. cd to Kubernetes, cd to YAMLs, and I've created a directory called ingress demo, cd to ingress demo. So I've got various YAML files for this demo. The first thing I'm going to look at is the HAProxy configuration. So let me log into the HAProxy virtual machine that I created. So I'm going to configure the HAProxy to load balance between kworker1 and kworker2. lxc exec HAProxy bash. Okay, lsb cat etc red hat release. As you can see, it's a CentOS 7.6 machine. The first thing I'm going to do is yum install HAProxy. Alright, HAProxy is installed. The next thing I'm going to do is I'm going to edit the HAProxy's configuration file. vi etc HAProxy HAProxy.cfg, and I'm going to leave the global settings and the defaults, and I'm going to delete everything after the global and defaults. Okay, and if I look at HAProxy.cfg from my repository, and this is the code that you need to add. I'm going to copy that and paste it here. Okay, so front end, the request is coming to port 80, and the default backend is HTTP back, and the backend is the load balancing type is round robin. So one request goes to kworker1, the next one goes to kworker2, the third one goes to kworker1. So that's round robin. And the servers that I'm adding are two servers, kworker1 and kworker2. So I need to add the IP address of those servers here. Okay, so kubectl get nodes -o wide. So kworker1's IP address is this one, and kworker2 IP address is this one. Okay, that's copied. Now we need to enable and start the HAProxy service. Systemctl status HAProxy. That's disabled. Let's enable it. Systemctl enable HAProxy. Systemctl start HAProxy. Status HAProxy. Cool, that's running. That's it. I can exit out of HAProxy virtual machine. We don't need to um, take care of it anymore. Okay, so we are done with HAProxy, and okay, let's create a deployment. But before that, I'm going to show you how to create the Ingress controller, right? Okay, so for that, you're going to head to your browser and search for Nginx Ingress, and it's this repository, Nginx Inc Kubernetes Ingress. If you go in there and go to the deployments, okay, go to the top level directory and then clone that Git repository. Copy the URL, git clone Kubernetes Ingress. Okay, so cd to deployments, cd to Kubernetes Ingress, Kubernetes Ingress, cd to deployments. Okay, so here you'll find all the YAML files, the resources that we need to deploy to create the Nginx controller. Okay, so we are in this directory, and if you go to deployments, and the install instructions are here. Okay, so first we're gonna run this YAML file, kubectl. You need to be in that directory, kubectl create -f. So that's going to create a namespace and a service account. If I do kubectl get namespace, you see the default namespace, but when I run that command, you see kubectl get namespace Nginx Ingress. So all the resources that we are going to deploy will get installed, will get deployed in this namespace. Okay, the next step we're going to do is we're going to create a secret. Kubectl create -f secret, that's done, and then a config. Kubectl create -f config created, and then RBAC. So this will create a cluster role and a cluster role binding. Okay, cluster role and cluster role binding got created. And finally, so this example shows either you can deploy it as a deployment or as a daemon set. I'm going to go with the daemon set because I've only got a handful of worker nodes. Daemon set deployment created. Okay. kubectl get all -n Nginx Ingress. So that's the namespace. Let's see what's happening. Okay, so the daemon set is getting created. The pods are getting created. Container is creating at the moment. It's pulling the Nginx Ingress image. It should be done by now. Okay, so they're all running now. Okay, so we have the Nginx controller deployed. So that's how simple it is to deploy the Nginx Ingress controller. That's it. So now what I'm going to do is I'm going to create a deployment and then create a service. Let me show you. So this time I'm going to cd to my Kubernetes repository, YAMLs, cd to Ingress demo. Okay. So in here, the first deployment I'm going to do is this one, Nginx deploy main.yaml. Let me show you what's in there. Nginx deploy main.yaml. It's a simple deployment which runs one replica of Nginx image. It's simple. It's a simple Nginx container image. kubectl create -f Nginx deploy main.yaml. kubectl get all. Okay, the Nginx container is getting created. Let's wait for it to create, and then we can expose this application as a service. kubectl get all. Okay, so our Nginx deployment is running. So we have created this deployment with one replica. Now we need to create a service of type cluster IP. So if you don't specify type node port, the default is going to be cluster IP. So we don't have any service here. So now let's go ahead and create a service. kubectl expose deploy Nginx deploy main port 80. Okay, so the service got created. kubectl get all. Okay, so you can see the service here, Nginx deploy main, and the services of type cluster IP. So we've created this service, we've created the deployment, we created the ingress controller. Now we need to create the ingress resource. Okay, so ingress resource one.yaml. Ingress resource one.yaml. It's a deployment of type ingress. So we are deploying an ingress resource into our Kubernetes cluster. We give it a name. Basically, it has the rules. The ingress resource contains a set of rules. So for this resource, we have just one rule. So if the request is coming from nginx.example.com, like I showed here, then the path, the backend, the route the request should take is the backend. The backend service name is Nginx deploy main. Service port is 80. So basically, we are saying if a request comes from nginx.example.com, please route it to this service, which is Nginx deploy main service. Let's create that. kubectl create -f. That's created. If you take a look at kubectl get ingress, you've got that ingress which we just deployed. kubectl describe ingress, and you can see host nginx.example.com, and the path is nginx deploy main. So that's the service name and port 80. Okay, so now what we need to do is we need to make HAProxy is ready, and the service is ready, ingress resource, controllers, deployment, everything is ready. So the only thing is we need to make a DNS entry for HAProxy for nginx.example.com. So as I'm not using a DNS server, I'm going to update my etc hosts file. Sudo vi etc hosts. Okay, in here I'm going to add the IP address of the HAProxy. LXC list HAProxy. So that's the IP address of my load balancer. nginx.example.com. So whenever I browse to nginx.example.com, it's going to resolve to the IP address of my HAProxy, and the HAProxy will load balance to one of these worker nodes, and the ingress controller on the worker node will route my request to the appropriate service. Okay, let's take a look at that. nginx.example.com. Let's try if it's working. nginx.example.com. Cool, so that's the Nginx welcome page, and it seems to have worked. Cool, so that's the a simple demo. Okay, let's try and add multiple applications to it. I'll just show you one more example. kubectl delete ingress 1. So now I've deleted this ingress. So these ingress controllers don't know where to forward the traffic to. So if I now go and refresh this page, you're going to get 404 because deleted the ingress resource. We have deleted the rules. So basically, the ingress controller doesn't know where to forward your request. Okay. In here, I'm going to deploy another two Nginx deployment. Vi Nginx deploy blue.yaml. So basically, it's similar to the other deployment, but here I'm using init containers. If you're new to init containers, I've done a video on init containers. Please search through my playlist and you'll find that video. So basically, I'm using init container to create a HTML file, and then on my actual Nginx container, I'm mounting that file under user share Nginx HTML, which is the default document root. And the HTML file is just a text saying I am blue in blue color, and that's the same for the Nginx deploy green. I just wanted to show you the difference. kubectl creates -f Nginx deploy blue.yaml and green.yaml. So I've deployed a couple more applications. kubectl gets all. So you can see we've got three deployments, but just one service. So I'm going to create a service for these deployments as well. kubectl expose Nginx deploy blue, Nginx deploy green, kubectl get all. So now you can see we've got three services for these three deployments, and all of them are cluster IP. Okay, so now we need to define an ingress resource. So I've got an example here. You can check this one. Ingress resource 2.yaml. So basically it's the same thing but with three rules. So if nginx.example.com is the host, then forward it to nginx deploy main. And if the request is for blue.nginx.example.com, forward it to nginx deploy blue service. If it's from green.nginx.example.com, forward it to nginx deploy green service. Okay, let's deploy this resource. kubectl create -f. Okay, kubectl get ingress. We've got that ingress. kubectl describe ingress 2. And now you can see these sections. nginx.example.com will be routed to this service. blue.nginx.example.com and green.nginx.example.com will get routed accordingly. Okay, so one more thing we need to do is to add DNS entries for all the applications that we create. Sudo vi etc host. So I'm going to copy the IP address because basically all the URLs will be pointing to the IP address of our load balancer. And I'm going to blue.nginx.example.com, green.nginx.example.com. Okay, so that's all needed. Okay, so now let's go back to our browser and see nginx.example.com. That's working fine. blue.nginx.example.com. Cool, I'm blue, so that's a different application. green.nginx.example.com, I'm green. And nginx.example.com, the default page. Okay, cool. I think that's all I wanted to show you. You can basically create any number of resources. This gives you an elegant way. So this is how you use Ingress controller on bare metal to route your traffic. So we've got a client. We create a HAProxy load balancer that load balances between the worker nodes, and then we deploy the Ingress controller either as a deployment or as a daemon set. We created a deployment, we created a service of type cluster IP, and finally we mentioned the ingress resource. So basically those are rules stating how to route the traffic. If a request is coming for a specific host name, where should that request be routed? So all those things. I hope um, this one was informative and you found it useful. If something is not working for you, or if you're having any problems with this setup, just leave me a comment. I should be able to get back to you. And if you liked it, please share it with your friends, and do not forget to subscribe to my channel. Um, okay, thanks for your time watching this video, and I'll see you on my next video. Bye bye.